monolithic chains have this negative network effect where the more users there are, the more applications there are, the slower everything is, or basically the more expensive everything is. It becomes like crowded and congested. And in a modular setup, we actually have these positive network effects where the more users there are, more applications, the more people running nodes, the more block size we can have.
All right, everyone. Welcome back to another episode of 0x Research. Today is April 10th, and we have an awesome conversation lined up with Nick White, the former founder of Harmony and the current co-founder of Celestia, where he spends his time building out a network of modular chains with Celestia focusing on data availability. But before we get into that, as always, we're joined by two members of the Blockworks research team, 0x Pibbles and Effort Capital, to join us for a little segment of Hot Seat, Cool Throne. Effort, I'll pass it over to you to start us out.
What I have in my hot seat this week is Flashbots and the MEV Boost Relay. So about a week ago today, 4 to 5 searchers were actually front run by a block proposer for approximately 20 to 25 million. So just a brief background on MEV Boost and PBS, Proposer Builder Separation. So one of the core ideas of PBS is that the block proposer, is not allowed to see the contents of a block they're signing until they've signed the block. Reason being is if they see the content of a block, then they have the opportunity to actually front run whoever put the transactions in that block and ultimately can profit from the opportunity. Theoretically, the way PBS is set up today, it's extremely hard for a malicious block proposer to deconstruct a bundle, see what's inside the block content, and actually front run that block builder and searcher. For them to do this, they have to either double sign, which is a slashable event, or they have to submit a block before the MEV Boost Relay is able to submit it to the network, which is extremely unlikely. What ended up happening was this block proposer was able to reorder the transactions in a block and included new transactions that was not inside the block when the builder gave it to them as part of the MEV value chain in Ethereum today. Pretty much it was a bug in the system for MEV Boost Relay. There's an ongoing patch that the community has been working on. I'm not sure if it's live today. Like I said, this happened about a week ago. I'm pretty sure it's live today. But as of today, we found out that Tether actually created a blacklist and has blacklisted the address that performed this exploit on MEV Boost. And that address had approximately $3 million of Tether on it. And it's pretty interesting for Tether to actually create this blacklist because they're very careful with doing so. I think one of their arguments against USDC was that they were very much more careful with blacklisting than USDC historically. So for them to do that, I think it's like a pretty big concern. And on top of that, Flashbots, if you actually go on their GitHub, they just created their own blacklist for anyone to use Flashbots as relay moving forward if there's any bad actors in the space. So I think as a whole, PBS and MEV Boost is like used by over 85% of the validators in the network today. Everyone thought it was relatively battle tested at this point, but we're already starting to see some issues in the system. And obviously down later in the roadmap for Ethereum, we want to see PBS enshrined in the protocol, following in the footsteps for all the work that Flashbots has done. But maybe it's time for the community to realize that maybe it's just not yet ready to enshrine it into the protocol because there's a lot of actors in this space that are all trying to figure out ways to exploit the system. So there's a lot of profit to be had.
Yeah, this is a pretty crazy instance of the attacker being the attackee, or a little bit of, what's the saying, a taste of your own medicine, right? So mevbots notoriously tear apart users and extract value from their transactions. And in most cases, they put up a ton of capital in doing so, right? You can put up $1 million just to come away with like a $5 to $10 profit. And that's kind of what happened here. This MEV bot put up a significant sum of value to extract just a couple dollars of value. And the validator reordered the transactions in such a way that they could basically drain all of the funds from the MEV bot. So I don't know. It's just like this little constant battle of how like the value chain of Ethereum and the players that are always looking to extract it. One thing I want to just make sure we point out is the Flashbots blacklist was specifically for the relay. So it wasn't like excluding that validator from the MEV Boost protocol as a whole, which is an important distinction, right? Because the relay is just one piece that anybody can pick any relay of their choosing. But I just wanted to point that out, that there is a little bit of a to make here, right? And I did see some of that going around Twitter that, like, oh, they blacklisted Ethereum's not decentralized, and like that's not really the takeaway to have here. But I agree with you, Effort, as well as you mentioned that the USDT blacklist, so they basically froze the funds of this validator that had taken these funds. And that's interesting, right? And that almost, I don't want to say this like for sure implies that there was a court order or some legal ruling that forced them to do this, but that's exactly where my head goes, is Tether probably had a reason that they had to do this. I don't think they're trying to make a statement with this, but I don't know. So that's kind of my takeaway, is like I expect more news to come around the legal side of this, which sets a really interesting precedent, right? If validators kind of misbehaving within a design system is considered an illegal offense, then I don't know if the takeaway of that is a good thing or a bad thing, but it's certainly something to chew on.
It's interesting because Ethereum's trying to create credibly neutral MEV solutions. And you could argue that they didn't do, to your point, Dan, they didn't do anything wrong. They did exactly, code is law, right? They did exactly what the code allowed them to do. And now they're getting penalized for it, which I would argue is the exact opposite of credibly neutral. It's an opinionated approach to MEV, saying you're only allowed to do what we think social consensus allows you to do, not necessarily what the code says you can do. So I think this is a really interesting, event that happened. And again, I think it's good though. It's good that, block creation is a purely adversarial environment. People are going to try to poke holes in the system to find ways of exploiting it. It just shows that PBS, and I think the entire ME value chain for Ethereum, just needs a lot more work until it's ready to be enshrined in the protocol.
Yeah, also positive too that it wasn't enshrined in the protocol in the current state, and there's kind of a time period where it can be battle tested until it actually is. So I guess we can count our stripes and feel lucky about that one. And I also agree with Dan in respects to, I'd be really hard pressed to believe this didn't come from an order. Like, I don't think Tether is in the business of monitoring Ethereum and making sure everything is working exactly as intended. So definitely agree with you there, Dan.
Yeah, and one more interesting takeaway that came out of this was Flashbots actually introduced just a little bit of latency into the process of MEV boost. It's communicating with the relays to prevent this from happening again. It was kind of like a quick stopgap while we think of like a more long-term solution. And that actually just so barely increased the block time of Ethereum from about 12 seconds to 12.2, which if you actually look at a chart of blocks created per day, it is like a noticeable downtick in the amount of blocks produced per day. So just as something to flag, if you see a crazy chart floating around with it, all of a sudden there's less blocks being produced on Ethereum, it was like, oh, that's a red flag. But there was it was intentionally introduced because of this incident.
Yeah, that was a good find there, Dan. I guess I can take it over for my hot seat. I've got Jared Gray and Sushiswap in the hot seat. This is a pretty easy one for anyone who hopped online Saturday night, saw that there was an exploit in a recently deployed routing contract. Not exactly everyone's favorite experience if you'd been using Sushiswap over the last 3 or 4 days since it was deployed. But yeah, everyone basically needed to jump on and revoke their approvals to avoid, being falling victim to the exploit. And I think it was in total about 1,800 ETH that was taken away from Sushiswap as a result of this. This also comes shortly after Jared Gray, the head chef at Sushiswap, got served a subpoena. So things aren't really looking great for Sushiswap. I know in our newsletter today, Westy highlighted everything Sushi's been through over the last year, and it is an exhaustive list. It's pretty crazy. But a good portion of the funds were recovered, and they're working with the Lido DAO to actually recover some more of the funds because some of them were sent to the Lido DAO as MEV payment. So it'll be interesting to see if they do return some of those funds to Sushi. Kind of sets an interesting precedent. I don't really know where I fall on, how I think this should play out. It seems like a bad precedent to set in some ways, but in other ways, you want to make the Sushi users whole if it's like an OG DeFi protocol. So I guess I'm curious, do you guys think they should do it? And then also, just on the topic of Sushi, if you had to take a guess, what would you say in terms of price? Do you think it's higher or lower in a year's time?
You just got to throw the whole Sushi protocol away. I'm sorry. Just start over. I think Lido should not return those proceeds. That's business, kiddo.
Yeah, I actually agree with you there, Pibbles. I don't know. It's like this responsibility, taking back the airdropped responsibility meme. That's kind of what just happened to this Lido validator, right? They were just doing their job, validating blocks, won the MEV lottery, and now they have this problem on their hands. Like, what do we do with these funds? Like, they were exploited funds, and now they're mine, but I did nothing wrong. And I kind of agree with you. It's business as usual. This is part of the process. Like, would it be the right thing to do to give it back? Yeah, there might be some like moral or ethical argument here, but I don't think they should have any legal responsibility. It's kind of the way I view it. What about you, Effort?
Yeah, I mean, I second Pibble's notion about throwing out sushi. Personal opinion, I think it's going to zero. Nobody uses it. It doesn't have it's not like winning product market fit like in any category. Unfortunately, it's an OG DeFi protocol. I do not mean any like personal disrespect. I don't know anyone that's using sushi. Let's call it what it is. When it comes back to Lido paying back sushi holders, I think it's nice if they do that. But I'm really curious, like what happens today, like the real world. If I steal money, and let's say I go buy a house, is there some type of like clawback mechanism, like in the real world, for like a legal entity, like an old house buyer that sold their house? Do they have to give back like the funds that were used in that transaction payment? I'm not sure, but again, it comes back to the rules of like code is law, or is it social consensus? If Ethereum is trying to be this credibly neutral platform, then it's just business, kiddo. Just like Bibble said, like you can't say it any better. That's literally what it is, and I don't think Lido should have to pay back.
We're bringing the FDIC to the blockchain.
Yeah, I strongly agree with everything everyone said. I don't think Lido should have to return those funds. It's just kind of the way of the road. And also just for the listeners who aren't familiar, Sushi's on a ton of different chains. So like that was just a mess for anyone who had used Sushiswap over the last 4 days. Like it's on like 10 to 12 different chains. So everyone was kind of worried if they had used Sushiswap over the last few days. But Pibbles, I think I can kick it over to you now for your hot seat or cool throne.
Yeah, hopping off of Ethereum, we have xNFT backpack on Solana is set to launch in like the next week or two. They got a big Saga launch for their crypto phone. This is a pretty big step for Solana. It's kind of the do or die moment, I think. Like they put all their eggs in this basket. Let's see what happens. I think xNFT backpack is super neat. There's going to be like the first NFT mint on the wallet happening by the end of this month. And it's really neat because you can just throw different dApps in there. Like they have like stuff like Aurora, which is like a Solana player in game, and even like Dexes. They have all the dApps living natively in the wallet, and then that wallet can also live on the Saga phone. So it's a totally new like mobile experience, and we do everything on our phones nowadays. So really excited to see how everything pans out. But this can also turn to a hot seat real fast if everything is just a catastrophe. So be super cool.
The Saga phone specifically is something I'm super excited about. Like it's certainly not something that I purchased solely for the reason of I'm of the belief, like I even took this with like Tesla cars, right? Like that when you're making this like crazy revolutionary product, the first gen iteration is probably not something you want to own, but is like very cool. And Tesla proved to be that. Like the cars fell apart, they're kind of shitty, but like they worked and they operated, and like that was the major invention. And then you fast forward to today, and like the car is, in a much better place. And that's kind of how I view this phone. Is like, yeah, it's going to be a phone and it's going to work and it's going to have really cool features related to crypto, but like it's still going to be clunky UX and like not that smooth. So that's kind of like where my head's at and thinking about how it's going to work. But if the off chance that's not the case, and it's just like a fully functioning, awesome to use phone that has these crypto native features, I mean, that will very quickly lead me to purchasing one. I'm pretty excited about it.
Yeah, strong agree. I'm excited as well. Like for smart contract platforms like Ethereum, like I look at them as really focusing on trying to lower the validator requirements to actually participate in verifying the network. But Solana for me is the one chain that's actually trying to build products built towards consumers that people actually want to use. And like, if we be completely real with ourselves, we have pretty much zero real world application for crypto except stablecoins. I think is like maybe the one you could argue that has some really good product market fit outside of Bitcoin. I think there's something there too. But yeah, I like the approach Solana's taking, and I'm excited to see how the Saga phone ships. And I also want one of those Mad Lad NFTs. I think the art is actually pretty sweet. It gives me some Peaky Blinder vibes for anyone who watched that show on Netflix.
Yeah, I can jump things over to my cool throne here, and I'm also going out on a bit of a limb here and doing a preemptive cool throne, and I'm going to put anybody who held through the Shapella upgrade in the cool throne, because in my personal view, it's going to be just another nothing burger event. You know, there's all these major hyped up things that we love to do that in crypto, is put all this attention around the next major thing, and then it happens, and just like this release, like, not a huge bearish event, not a huge bullish event. It's just like operations as normal. And that is exactly what I expect to happen when the Shapella upgrade goes live. And so right now, just to give some stats, to give some context, there's about 18.1 million ETH staked, which equates to about $34 billion, and 1.1 or $2 billion of additional ETH rewards. So the actual staking rewards that validators have accrued since being live on the Beacon chain. In my view, the with rewards are very likely to be withdrawn in like a high capacity, right? You know, if you staked, let's say 6 months ago, 7 months ago, now you're like actually trying to realize some of this value. And so the rewards, yeah, 2 billion of sell pressure. Okay. That's like how many minutes of proof of work consensus security? Like, okay, not a huge deal to see $2 billion of sell pressure in my view. And I really just I'm not buying into the narrative of like everybody's super eager to unstake and sell. That logically that just doesn't add up. And I'll give you a bit to color as to why, right? If this upgrade was happening exactly 12 months ago, and let's go 8 months ago, and we're 2 months after the Terra collapse, I'm terrified because the sentiment in that time was like, everything's going to zero. It's the end of the world. Like, buckle up. And that was pretty much the case, right? Then like 3 months after that, FTX blew up. Things just kept getting worse on a consistent basis. But if you made it through all of that, you're at 12, like we're at what, like 12 months, 13 months into the bear market now. Like, the light can be seen, the light at the end of the tunnel can be seen by everybody. And it doesn't, I just really struggle to make the logical gap that people are going to withdraw their entire stake position in mass and proceed to just sell it. And Mark Zeller, who works for Aave Chan over in the Aave protocol, had a really good point on this. And you can actually see through some of the ETH clients, the software you're running to operate a node, you can actually see if people have already opted into getting into the line to withdraw. So you can't withdraw yet until the upgrade goes live, but you can actually get in line. And by getting in line, you do sacrifice your future rewards. And so the upgrade is slated to go live Wednesday, April 12th at about 5 or so a.m. Eastern time. And this episode is going to go live somewhere around 7 hours after that. So we'll see how horribly this cool throne panned out. But so far, there's been a very, very small, like an immaterial fraction of validators have already opted into that line. And at this point, all you're doing is basically electing to not receive 1 day and 12 hours worth of rewards. And if you wanted to be first in line to dump your whole position and sell it, that is very much I need to be first game, and nobody's taking up that opportunity. So personal view, it's going to be a nothing burger. That doesn't mean that's going to be some massively bullish event, unless you're under the idea that this massive bearish event is already priced in and then just doesn't happen. But in my view, we're just going to keep trading sideways, and that's what's going to happen. Is again just a big nothing burger.
Recommend no preemptive cool thrones like these for the sake of our industry.
And certainly not financial advice either.
Yeah, we're actually gonna just brick the entire Ethereum network. That's what Effort said earlier. And this is gonna be the biggest black swan in the history of Ethereum.
Let's hope not. Yeah, like Effort said, for the sake of our industry.
I agree though, Dan. Like, overwhelming majority of institutions that are not necessarily crypto native but own Bitcoin and ETH, they're not staking today. They're not taking the risk. They don't understand the technical, they don't understand like the technical hurdle, I guess, related to Shapella. They don't trust the Ethereum community. They don't trust crypto natives. They're just like, I'm going to wait and see. If it goes well, I'm going to stake. If it doesn't, I'm just obviously going to probably sell my ETH. But assuming everything goes well, I have to imagine staked ETH like goes up to over 20%, maybe not by year end. I mean, as of right now, it's on pace to do that, even before Shapella. But heading into Shapella, you're still seeing more ETH getting staked. It's not slowing down. So that leads me to believe that It's more of like a confidence event where people are going to realize that everything's good. Let's stake our ETH. ETH becomes even more money. It becomes more of a yield bearing asset in the ecosystem. I see it as a bullish event for ETH and crypto as a whole. And obviously today we'll see how things pan out on Thursday. But as of right now, the market was moving up higher on the news, like leading into Shapella. Whereas typically you would think that it would kind of be like a risk on event where the market would kind of sell off heading into it. So I think it's just an overall interesting market climate right now.
Yeah, I think like the main withdrawals is honestly going to come from people who locked in their ETH like a year ago, like into like really shitty structured products. Like, so for example, I've got $150 of ETH staked on Coinbase that's just been stuck there. And actually, now that I think about it, I haven't tried to actually convert that to CB ETH. But I think generally speaking, mainly people are going to be selling that entity is going to have to withdraw based on, customer deposits. And then that customer is ultimately going to go to a decentralized derivative because it's a lot more useful and can be used in different applications. I guess that is another interesting thing to think about though, with CBETH that I just thought of is like, if there is no way to convert that staked ETH into CBETH, if Coinbase doesn't automatically convert that to CBETH for you, and then people do sell to get into decentralized alternatives, then maybe there'll be a nice little discount on CBETH. Like I expect the real plays to actually come from like little outlier situations like that more so than I do like if there's actually anything here with the unlocks actually opening up. So agreed, Dan, nothing burger.
Yeah, and over this weekend, I actually saw CBETH was still trading at about like a 1.5% discount, which is pretty interesting because if you look at Lido staked ETH, that's at I think the peg I last checked was 0.9966. And Frax ETH, for example, 9991. I just wrote something about this earlier today, which is the only reason I just know those numbers off the top of my head. But then you see a whole 1.5% discount on CBETH. So maybe there is something there. I never dug in. It was over the weekend, so just didn't really open that chapter. But that is an interesting thing to think about. And I want to say, but not 100% sure, that there was like a terms of service agreement that you had to like opt in if you had that OG version of Coinbase staked ETH to kind of move that over into CB liquid staked ETH. So that could be something at play as well. But I think that's a great place to wrap the intro, guys. This was a fun one and super excited for the listeners to head over to this interview with Nick White. It was a super exciting conversation and you can really hear how motivated he is to just like talk about Celestia. So super exciting. And without further ado, Nick White. Welcome, everyone. Well, we are joined by Nick White, the co-founder of Celestia. Nick, thank you so much for joining us today. We're super excited to dive into the weeds on everything Celestia is doing, but we'd love a quick little intro from you, kind of your background and what led you to founding Celestia.
Oh, thanks for having me, guys. I was listening to some of the previous episodes and overall, like the Blockworks podcast has really taken off as one of my top listened to podcasts recently. So you guys are doing a good job.
Love to hear it.
Yeah. So I'm Nick. I'm the COO of Celestia Labs. I got into crypto back in 2018. Actually, originally in college, I studied electrical engineering, specifically like neural networks. But I left AI because crypto just kind of grabbed me as this thing that was actually going to make the world a better place, and that it's going to empower people to sort of be more self-sovereign. I co-founded this project called Harmony in 2018. My whole vision was basically this technology is so powerful, but it's not scalable, essentially. Like in the way that it's currently built, it's not going to be able to have the impact that I think it could have, because the reality is that not everyone will be able to have access to it. And so that's kind of been my mission since those days. And originally with Harmony, we were trying to solve that using sharding, but I ended up realizing that sharding was not the right approach when I read this white paper called Lazy Ledger back in 2020, which gave this whole new vision for how to build blockchains in a modular way that, in my mind, actually solved all the core problems of blockchain infrastructure and could be the foundation on which we could build truly scalable, decentralized networks. And so that's kind of been my thing since then. And now fast forward to 2023, we're really close to launching mainnet. So stoked to be here.
So can you give us a background on the main problems that Celestia is actually trying to solve? And I'm also curious, like, how far away are we from some of this stuff coming to fruition? Like, what do you actually see the typical architecture of blockchains looking like in, let's call it 1 to 2 years?
So to understand what problem Celestia solves, we have to first back up and talk about what problem do blockchains solve, right? So blockchains are like a verifiable computer, meaning that anyone can look inside of what's happening on a blockchain and verify that the rules are being followed. And this is unique. It's something that you can't do in Web 2. In Web 2, like, for example, Facebook runs the Facebook application. You don't actually know what they're doing. You're just kind of a consumer, and they can make rules unilaterally and change things on you. And in Web 3, the thing that's different is that users actually kind of define the rules and enforce them. And so why is that challenging? Is that if I, as a user, want to verify everything that's happening, I end up having to run it more and more, like have a bigger and bigger computer, the more things I need to verify. So in a standard monolithic blockchain, as the amount of applications increases and the amount of transactions increase, I have to verify every single one of those transactions, every single one of those applications. And that doesn't scale. So the problem that Celestia solves is that it allows you to actually have a ton of applications and have a bunch of transactions, and users are still able to verify them. So you preserve the core value proposition of what a blockchain is while still being able to increase the capacity of the network. So I can talk a little bit about how that works if that's interesting.
Yeah, please do.
Yeah, so the way that it works in a monolithic blockchain is all the transactions, right, get packaged into a block, and then attached with that block is a commitment to the new state of the chain. So the new, let's say like it's Bitcoin. It's what kind of balances does everyone have? And obviously if there's billions of people sending billions of transactions, the block size gets bigger. So there's more data in that block, and there's more transactions to verify one by one. And so now if I'm an end user, I need to verify all of those things. I need to download the whole block, and then I need to re-execute every transaction and then compare it to the state that the block commits to, right? And in a modular blockchain, you're able to break that problem into two separate things. So the first thing is that rather than re-executing and verifying every transaction individually, you can actually use something called a rollup, which means that one computer, one node, can do all the verification for you and just show you a proof that the work that they did is correct. So you can tell for yourself without actually having to re-execute every transaction that the state is correct. So it's like, okay, I know that all these are all the right balances. I don't have to actually do the work myself. But the thing is that in order for that whole construction to be secure, you still have to know that the block data was available. So like if in the previous monolithic world, you would have downloaded all those transactions. Now, instead of downloading them, you just have to make sure that they're there, that they were published on the internet. And so that's its own separate problem that Celestia solves, which is that the Celestia block data is made available in a way that nodes can check that very, very in a very, very light way. So they can download less than 1% of the block and verify with 99.99% security that it is all available.
Okay, great. That's super helpful context. So if we look at the current state of rollups on Ethereum today, though, would you say that they're kind of missing the forest for the trees by just trying to build out more low-cost EVM block space, and that data availability will become a bigger problem, and that's the problem you're essentially trying to solve for? Is that like a fair take?
I think, yeah, at the end of the day, the ultimate bottleneck will always be data availability, like just the raw block space. That's like the raw material on which every decentralized application will have to consume. But I think in terms of like the difference in the vision between sort of Ethereum and I guess Celestia is that in Celestia, we were able to start from the beginning with this insight in mind, which is that actually blockchains should be modular. This is the way that we should design them. And so we were able to basically throw everything out about how blockchains are typically built, and start from scratch with a purely maximally modular design, essentially. So Celestia does no execution on the base layer. It's literally, well, the original paper was called Lazy Ledger because it's a lazy blockchain. It almost looks like it's pointless because it doesn't do anything except for making data available. And so we're kind of with this, we have this privileged position of being the first modular blockchain network where, we were able to start from first principles and designed from the ground up. So I think that's kind of the main difference.
Hey everyone, big announcement from the Blockworks Podcast Network. We're launching a new show called Lightspeed and hiring 2 hosts to come build it with us. Lightspeed is a show for builders focused on the use cases that will onboard the next generation of crypto users by taking learnings and inspiration from the garage days of Silicon Valley. We really want to capture the perspective from builders because that's what the ethos of crypto is. Constant experimentation and relentless innovation to build products that users can't resist. If hosting a show like this sounds exciting to you, then head over to the careers page on blockworks.co, which we have linked in the show notes. You can also reach out to me or Sam on Twitter to talk more about the opportunity, but overall, we're stoked about Lightspeed. So if you think you'd be a great host, please do not hesitate to reach out.
And then in terms of cross-chain composability, when you think about chains that utilize Celestia for data availability, what are the main bottlenecks there? Is it required, for example, that any chain that wants to be composable with another chain that's using Celestia also has to be using Celestia for DA as well?
That's a good question. There's a great blog post that our co-founder Mustafa Al-Bassam wrote called Clusters. And in that, he paints this sort of like mental model of how interoperability looks, right? And there's an impossibility result that is that 2 separate chains that don't share a common data availability layer can only interoperate with trust assumptions. So they basically have to like either assume the other chain is honest, or you can use some kind of committee in the middle, but there's no way to actually have like trust minimized cross-chain interoperability. And one of the beautiful things about having a data availability layer like Celestia is that 2 rollups, if they share Celestia or any common DA layer, they can interoperate in a trust minimized way. So what we call that, the mental model that Mustafa used is clusters. So you have like these clusters of chains that share like this kind of, I don't know, border of security. And then whenever you want to bridge outside of that cluster, you have to end up making new trust assumptions. And this is really important it's not that important at today's scale of blockchains, let's say, when you only have maybe like 10 like legitimately used secure chains. But in the future, in the long-term future that we believe in, there's going to be millions of blockchains. And when you get to that scale, you're going to really want to make sure before you connect to a chain that it's within your, cluster, so to speak, right? Or you're going to be very selective about the chains that you bridge out to outside of your cluster. And so having one way to think about Celestia is not just that it's like this consumable resource of DA, but also that it's like this network, right? That's why we call it the modular blockchain network, is because it's sort of like all these modular blockchains that are plugged into Celestia are all part of one unified ecosystem.
Okay, that's interesting. So that begs the question then, is this kind of a winner takes most space, would you say? Like, I know there's a lot of other providers, like you have EigenLayer, you have Polygon Avail, but when I'm thinking about it intuitively in my head, it's kind of like the more chains that are using your service, the more value that's accruing to that token, which is ultimately securing the data and ensuring that it's available. So would you say that this is kind of a winner takes most market, or do you think it's plenty of room and there'll be enough activity where a lot of different solutions can thrive?
That's a good question. I think long term, you see a lot of like power law distributions and lots of different like areas of technology. And I think there are network effects to data availability networks. I don't think security is the most important thing. I think it's more about sort of the ecosystem, or I don't know, there's a lot of different dimensions, but I don't think security will end up being the one that sort of like causes that flywheel necessarily. But in the short term, it's such early days, and there's so much growth that I don't think like it's important to like think about it in that sort of negative sum mindset. I think it's very like positive sum. And I think the more experimentation and the more different versions of data availability layers that people build, the better. And also, frankly, there's just going to be a differentiation in terms of different features. So like, data availability layers might have different consensus algorithms, or they might have different data availability schemes or different interfaces. And all of those things might, be useful for different kinds of applications. And so roll-up developers might choose a data availability layer, for other reasons, essentially, than just these network effects. And so I think it's important that we kind of explore the trade-off space here. And the interesting thing is that this trade-off space basically has not been explored at all. because we're really entering this new era. And so I think and I hope that there's going to be a lot more projects, choosing new like interesting designs essentially. And that's also one of the reasons why we have this saying, modularism, not maximalism, because we really believe that like what we should be building are a bunch of different like components for developers to choose from, and that like we're building this for the end users and the developers, and the more like variety there is, the more like trade-offs they have to choose from, the better for everyone. So that's what we believe.
Yeah, that's an interesting point. But from a larger standpoint, that does bring up a good point around security, though. How does Celestia guarantee the accuracy of the information that other chains using Celestia for their data availability can rely on that data? What is there like some sort of economic guarantee, like a standard proof of stake system, or how do you guys think about kind of providing that security?
Yeah, so security is a topic that a lot of people in blockchain like get wrong, in that so there's different dimensions of security, right? So you can't really bundle it into one thing and just say this is security, right? So there's a few different things that blockchains provide, and all these kind of get bundled into security. One is sort of like consensus, or what I would call this. It's something that Nick Carter wrote this piece on way back. It's called settlement assurances. It's like, hey, once I've sent my transaction and it's included in a block, how settled is it? Like, how hard would it be to rewrite that transaction? Like, how costly would it be essentially? So there's an economic cost if you want to revert the chain and reorg it and get rid of that transaction. And so that's one element of security. And proof of stake or any consensus algorithm, what it does is it provides you those settlement assurances, right? Like once something, so in proof of work, every time there's a new block added, it's like, well, if you want to mine a new block, you have to pay all this energy to make a new block, right? If you want to reorg the chain. So there's actually an economic cost. And the deeper it goes, the bigger that cost become. In proof of stake, it's similar. It's that once that's in a block, if you want to fork the block, someone's going to have to basically burn a ton of their stake. And so there's that side of security. And that is dependent on the value of the token, the value that's staked on the network, right? But really, like, the more important side of security is what I would call validity, essentially, which is like, is this block valid according to the rules that we've set out, right? And so this would be like in Bitcoin, if I try to send a transaction that spends coins that I don't have, like that's invalid. And this is really, I think, even more important than like reorg resistance, because like ultimately, if someone can just mint infinite coins or break the rules and steal all your money or something, then like the whole point of the blockchain is basically pointless. Versus like a reorg, it's bad. It's like someone could do a double spend, but to me that's orders of magnitude less bad than like completely breaking all the rules. And so validity security in a blockchain is actually independent of the consensus mechanism or the value of the token at stake. It depends on basically people running full nodes. So how easy is it for someone to run a node that fully verifies the chain? And if you're running a node that fully verifies the chain, then you have like true validity security, if you will. And the beautiful thing about Celestia and modular blockchains is that we really, really, really emphasize that, which is we want all users to be first-class citizens. So we want people to be able to verify the chain themselves. And they can do that with the modular blockchain using something like a smartphone, because you can run a data availability light node on your phone. You can run a roll-up light node on your phone. And you can't do this like obviously with Ethereum or Solana or any of the monolithic chains, because you actually have to you can't even run it on a laptop in a lot of these cases. You have to have like a cloud instance, and that's the only way you can verify the chain. Or even a lot of people in Ethereum just use an RPC endpoint. They just talk to someone else running a full node. So like the whole security model of blockchains is like completely broken in the monolithic model. And that's something that we want to fix. And so in that sense, when people are talking about like, oh, well, the security of Ethereum is going to be bigger. It's true that the consensus security will be bigger if it has like more value at stake, but like the actual security from a user standpoint will be much lower unless they have these like fully verifying light nodes.
Interesting. I think that's actually a good time to hop into really what a light node is and what exactly you can do with them. I saw you tweet earlier, actually. Definitely wasn't stalking your Twitter before this, but I saw you tweet something along the lines of a smartphone with an app store where you can pick different light clients to actually run. So can you kind of like, I guess, just paint the vision of what light clients are, and like how you see them playing a role in the future?
Yeah, well, I mean, I'm really passionate about this, but like the future of crypto, the way that I see it, is that everyone in the world with a smartphone literally can connect to this verifiable network of applications, and that can be payments, it can be DeFi, it can be literally anything, and it's like this peer-to-peer network that they can fully verify and transact with anyone else in the world in a trust minimized way, and and I think modular blockchains are actually paving a way to get there. But what we need to do, like we have now the technology, like it's possible already to run a Celestia light node on a phone. Mustafa has done it. Like many people have done it. You have to have an Android phone, unfortunately. And maybe they'll put this in the Solana phone. I would love to see that. So it's possible, but now we have to make it really easy. So we have to make like applications that people can just download and install and have them running. We need to do the same thing, not only for the Celestia light nodes, but for like the roll-up light clients. Because Celestia, like so if you want to fully verify an application running on the modular stack, you have to run the data availability client. So you're sampling all the data. You also have to run the roll-up client, which is that you are listening to the roll-up chain and verifying the fraud or validity proofs. And so we need to make both of those very, very easy for people to do. And my vision for that is that there will be some sort of app store, essentially, like an app you can download, and it's running a Celestia light client. And then at the same time, when you're like, oh, I want to start using this DeFi app chain or roll up, you click download, and all of a sudden you start sampling and listening to that chain too. And so like you can sort of like choose what parts of the Web3 ecosystem you want to participate in and verify. And like I hope that people will be able to verify everything that they're part of, that they can be first-class citizens of every network that they want to be part of.
So I know you guys are pretty tightly tied to Cosmos, of course. So how do you see Celestia's playing a role in Cosmos for app-specific chains versus, I guess, something like Ethereum or something like a sovereign rollup? Like, where do you think most of the activity will occur, and like, what is going to be, I guess, the most dominant architecture? And I know that's really hard to predict, but what's your best shot at it?
Good question. So as people know, we are very aligned with the Cosmos ecosystem. We've even built a lot of the Celestia blockchain with the Cosmos stack. So we use Tendermint and Cosmos SDK to build like the base of the Celestia chain. And I also just want to make a side note here, because this keeps coming back up, but there's a difference between modular software and a modular like blockchain protocol. So like Cosmos, for example, invented this idea of like modular blockchain software, meaning that Tendermint as a library, not a library, but as like a piece of software, and Cosmos SDK as another sort of like software stack are modular. They separate consensus from execution in the same way that Celestia separates consensus from execution, but in the protocol stack. And there's a big difference, which is that with the Cosmos SDK and Tendermint, a lot of people build monolithic blockchains that don't actually, like the blockchain still is monolithic and not modular. Anyway, just wanted to insert that for people's awareness. Now, the beautiful thing about where Celestia and Cosmos intersect is that we share this vision of sovereignty, which is that not everyone should be building their applications on one shared monolithic state machine. And there's a lot of reasons for that. One of them is that you want to have customizability, right? And it's not necessarily like all the way to the app chain level, but like, let's say you just want to add new opcodes to the EVM. It's so difficult. Why is it so difficult for them to add something like account abstraction? Or there's been so many improvements to the EVM that people want, like parallelization. Why is it so hard? Because there's only one state machine that everyone has to share, and any changes could break everyone else's applications. So they necessarily have to move really, really slowly. And so the beauty of decoupling applications into their own chains is that you can actually experiment more and you can optimize your like virtual machine to the kinds of things that you want to run. And I think that's heavily underexplored and something that like we strongly believe in. The other thing is sovereignty itself, which is that if you're embedded into the like Ethereum state machine, then you're kind of beholden to the Ethereum consensus, like social consensus. So if something happens to your application, you want to fork or upgrade or do something different, you have to convince all of the Ethereum community to go along with you, which now Ethereum is so large and diverse that it's like basically never going to happen. And so having your own chain is a really powerful thing that I think people will start to realize is like so much better vision for the future of blockchains than like having one monolithic state machine that everyone is like wrapped up inside of, because it's just everyone's going to be like tied up and kind of constrained from that. Now the thing that's different about us and Cosmos is that with Cosmos, the challenge is two things. In order to launch a new chain, you have to bootstrap a new consensus network and a new proof of stake token. And that's a huge amount of work. Like people, you think that, oh, the hardest thing about launching a blockchain is software. It might have used to be that way, but now with the Cosmos SDK and Tendermint is actually pretty easy, but you still have this high overhead of coordinating the social and financial side of it. And Celestia basically eliminates that by being this self-service consensus network. So you come to Celestia and you say, hey, I want to launch a chain. Oh, great. You already have this set up for me. I get consensus and data availability out of the box. I just have to write the logic essentially of my chain. And then you take care of the rest. I don't have to issue a token. I don't have to worry about securing my network. And then the other thing is in Cosmos, they have probably the best, I would say, interoperability standard today, which is IBC, and it works extremely well. But as we talked about, like in the future, when there's lots, like thousands and millions of chains, IBC still makes that trust assumption. You're always kind of bridging outside of your cluster. And so Celestia also solves that problem, which is that it can be the security layer for the interchain and allow these different sovereign chains to talk to each other in a trust minimized way.
So yeah, that's super interesting about the broader Cosmos there and being that interoperability layer. I'm also curious. So last week we had Preston Evans on, who came and talked to us about sovereign rollups and was very excited about using Celestia as the DA layer for sovereign rollups. And a couple weeks back we had John Adler on, who's building Fuel, and he was super excited about kind of plugging and playing that execution layer with Celestia and potentially another blockchain for settlement. And so when you look at all these options now, I'm curious, which ones are you most excited about or think have the most potential to be like very exciting or maybe where more users or more, I don't want to say users, but what is the most promising configuration of these modular pieces to make the best blockchain?
It's a good question, and I don't want to cop out, but what I will say is I truly do believe in modularism, not maximalism, in that like there isn't, like, people have been searching for a long time, like, what is the ultimate perfect blockchain? You know what I mean? And it's like, no, it's Solana, it does all this stuff, or no, it's Avalanche, or it's like, and this mentality is like there's one design to rule them all, and that is basically Celestia is like taking the opposite approach, is like the antithesis to that, which is that like there actually is no best design. In the same way, like if you asked a web developer, like what's the best, I don't know, like setup for your thing, it's like, well, it depends, right? Like, well, I'm going to choose what is best. I'm going to first think about what am I trying to build, and then I'm going to go back from there and say, okay, these are the pieces I need and the components I'm going to hook up, right? And so that's kind of the way that we see it. But within that, like, there's a lot of different like components to explore that seem like they will be very useful, depending, like, for different kinds of trade-offs. Obviously, the Sovereign Labs team, I think, is really brilliant, and I'm really excited for what they're building, because I do think that in a lot of ways, like what Preston was saying in the episode, like ZK rollups have a lot of advantages when it comes to interoperability and all of that, and they're really easy to make light clients for. And I think so I'm very excited for that. I'm excited for more like rollups as a service kind of thing. I actually think that there's a huge demand for people to be able to sort of like one click deploy and have all of that sort of taken care of. Like that is our end vision, is that like my end vision. So similar to this like app store light client thing, that's like the user experience I want to see. The developer experience I want to see is like you go to like a portal and it's kind of like AWS and you choose all these different configurations. Like, okay, I need this much. I want this kind of VM. I want to have this kind of sequencer model. I want to have, these kind of like light clients or whatever. And then you just press go. And then like the chain like magically spins up. You don't think about anything else. And you're off to the races. And so that's what I want to see. And I think there's going to be just like a huge amount of demand for someone whoever like really makes that developer experience like just super crisp is going to do extremely well. And I guess another thing that I want to say is like one of the most promising things, the thing that was like most worrying me about this, of like making this possible, was just the fact that like spinning up a new sequencer set is like, obviously everyone knows that like a lot of chains right now are centralized sequencer. Optimism, Arbitrum, basically every rollup in existence right now is still centralized. And that's not good from a liveness and censorship resistance standpoint. And so we want to move towards more decentralized sequencer rollups. But the problem is if you want to launch a decentralized sequencer rollup, it seemed like the only way to do that is to basically like create a new sequencer set every time. And that kind of becomes almost the same problem as launching your own blockchain. And so I was very worried that like, okay, this is going to make things kind of impractical or kind of decrease the value proposition that we were originally trying to go after. And the beautiful thing is that like now I feel very confident we're going to solve that. There's all these new projects tackling decentralized sequencing, and there's like some very compelling ways to actually solve the problem in a way that is decentralized and trust minimized. And so yeah, we can talk about that. But Astria obviously is one that recently announced. There's Espresso. There's a handful of other projects. I think even Flashbots might be looking into something similar with Suave. So that's what I'm also really excited about. I think that's the next most important layer of the modular stack to get right.
Yeah, strong agree with that. We definitely need higher accountability, I guess, for decentralizing sequencers. But to play devil's advocate a little bit, so Arbitrum and Optimism have their native tokens, ARB and OP, and everyone's like, oh, like they'll accrue a lot of value as soon as the sequencer is decentralized with their token as like a proof of stake economic security model, or an MEV will be extracted that way. So I guess my question to you is, why would an L2 want to use, let's say, a data availability service or a decentralized sequencer when their token's not involved in the value accrual process at all?
Yeah, that's a good question. So the Jesse from Variant put out this really short blog post and tweet the other day, which is basically about like networks versus libraries, right? And the point was that networks in Web3 are fundamentally kind of new in that we have a way to sort of like generate economic value from networks and sort of like have them be owned, and they have a reason to sort of have a token and so forth. Whereas there's also libraries where for example, like ERC 721 is a library, right? But it doesn't, it's very important and it's very useful, but you can't really build a network around it, right? And I thought that this was a really good framing because it kind of articulated something that I've been thinking for a while. And why this is relevant to rollups is that when I think about what a rollup is at the end of the day, there's two sides of it. One side is the library part, which is like, hey, here's the execution environment, and here's like sort of like the proof system and model that we're using to secure the rollup, right? And then in theory, anyone could take that, like they could take Arbitrum's code, like the library side of it, fork it, and deploy their own rollup. The only thing that's stopping people right now is the business license, for example. But and then there's the network part, which is like, hey, I'm going to launch a rollup like the Arbitrum main chain that is sort of like the network behind the technology that I built. And so anyway, like I think that it's true that if I am building a rollup that I want to like sort of own this network, I guess I might want to sort of own, like I need to justify having this token And maybe the way to justify that is to sort of like also run the sequencers and be a little bit more vertically integrated. But I think in the long term, like the average developer is going to be building, like they're going to take this, like the libraries, like things like what Sovereign Labs is doing with the Sovereign SDK. Like it's a library. Someone's going to be able to take that, launch their own chain. And I don't think they might not even want to have a token. They might have a different kind of business model or use case, right? Or maybe the token is useful, but doesn't need to be justified for the sake of decentralized sequencers. It could be part of like the built-in application, for example. And that's the network that they're building. So I think it makes sense. It's more scalable and secure long-term when we pool resources, right? And I think having a shared sequencer network is another sort of like natural sort of like pooling of resources into one common network that people can launch on top of. A few other things, just while we're on the topic, is like you get a lot of benefits on using a shared sequencer, like cross-chain composability between these different rollups can be ensured because they're sharing the same set of nodes that are ordering their transactions. So like there's a lot of reasons why I think shared sequencers will end up accruing a lot of the sort of roll-up ecosystems.
Yeah, I agree with you too. And it's almost like once one of those or two of those kind of gets that Lindy effect, then you're almost at a disadvantage not being on that same shared sequencer, right? If you don't have that easy composability with all the economic activity that's happening, you kind of put yourself at a disadvantage. So that'd be an interesting state to see if we actually reach. But I want to back up a little bit there. And, you mentioned that end state that you described with like the developers logging into this portal and kind of like building your own chain with everything that exists. And I'm curious to get your take. Like, where do you think Ethereum stands to really fall into in all this?
Good question. I mean, I think where Ethereum is going is actually very modular. They are, basically moving to make the Ethereum base layer just like a DA layer. And so I think like in that portal, right, like you'll be able to probably choose between different data availability layers to plug into. And I think Ethereum dank sharding will be one of those layers. I think the only difference, again, going back to, we touched on this earlier, between, for example, Celestia's vision and Ethereum's, is that Ethereum does have this baked in execution layer, which is an advantage, but also a disadvantage. And so it's a set of trade-offs. The advantage of having, the ETH L1 execution is that you can have settlement, right? And there's this rich, pool of assets and users that are already on the ETH L1. And now when you launch a rollup, you can have a bridge down to that ETH L1, and it has like, it can be sort of like this, the root of the ecosystem, if you will. The disadvantages is that then you now have a more stateful sort of like complex layer one that's not as minimal or modular. And so Celestia's kind of choice is like to eliminate that and to be maximally minimal and maximally modular. And so we don't have any execution. And so a lot of people are like, oh, well, then where am I supposed to settle my rollup? And actually, we should talk a little bit more about like smart contract versus sovereign rollups. But basically, Celestia thinks that in the long term, settlement should not be on the layer one. It should not be coupled with data availability, and instead should be sort of its separate thing. And that's either settlement via sovereign rollups or settlement on specific rollups built on top of Celestia that specialize in settlement, rather than kind of enshrining something from day one.
So speaking of settlement, Celestia, some people will argue one of the downfalls is that you can't have a two-way trust minimized bridge. How would you respond to that? What are the trade-offs and what are the benefits really?
Yeah, so I actually agree. And I've been like kind of, it's something that bothers me right now about Celestia right now, is that we don't have a trust minimized way of getting the Celestia token up a layer above to the ecosystem. We do have a way to do that. We can use IBC, or again, I don't want people to get mistaken that like there's no way to get the token up. It's very possible, but you're going to use, it's not going to be this trust minimized bridge, but which anyway, by the way, none of the rollups really have trust minimized bridges right now. Like they all have multi-sigs, or like, for example, even Arbitrum, they are like, a lot of them, the fraud proofs are not actually active. So I also just want to say that like there aren't very many trust minimized bridges in the wild anyway. So it is not really that different. But like, at least as of now, there isn't a trust minimized way to get the token up. However, we've actually come up with some really, really interesting ideas around how to do this. One is like, for example, we could do basically interchain staking, which is the Cosmos version of restaking, to create sort of like a parallel like settlement chain or like a bridging chain that bridges up to rollups. Or there was another interesting idea that we had recently, which is that we could, in the same way that like what Bitcoin's doing, we could have specific sort of operations within the state machine that can verify ZK proofs. And by doing that, it's like a stateless way of us basically being able to bridge tokens in and out of the Celestia base layer. And I think that's actually a really cool one. It will obviously take a little while to be built, but like it's going to happen. It's just that the reason why we haven't committed to anything is that we want to do it in a way that preserves the minimalism of Celestia, because we think that that's sacred, and so we're trying to figure out what is the right design that makes the right trade-offs, essentially. So yeah, hopefully that answers your question.
Yeah, it does. I'm curious, is the reason that you and your team is thinking about this is because you want to ensure there's enough, I guess, economic value around the Celestia token so that it can secure the chain from an economic standpoint? I know you already mentioned earlier that you think there's other reasons to prioritize for security over the proof of stake value that can be slashed, but I'm curious if that's why you guys are thinking about a two-way bridge.
Yeah, I mean, I think of the Celestia token as being a very critical part of the overall modular ecosystem on top. And I think that, there's going to be demand anyway to, I think, bridge it up and use it as collateral, or maybe even Rolos may want to use it for fees, or, I can't even imagine all the different ways that people might want to use the token aside from just staking. And so it seems very silly to me to limit the utility of the token simply to staking. And like in the future, let's say there's like liquid staking derivatives. It's like, okay, well, I've staked my token. Now I have this, staking derivative. I want to actually use it in DeFi or what have you. I do. Basically what I'm saying is, yes, I think it's important that the token can be free. Right. And this is true even in like traditional finance. Like if I have a bunch of Apple shares, right, like I also might, borrow against them or what have you. Like it's ultimately it is an asset that I think like should be, able to be tapped into in lots of different ways.
Great. That's super helpful. This one's really in the weeds here, so hopefully it makes sense. But so I've read about, obviously in the Ethereum roadmap, you're going to want to use Erasure Coding in order to sample the data and ensure that it was actually extended correctly. So you need these light clients to be able to check that in the case of Celestia. So everyone always talks about, you need to use a 2D square. So that way you only need to download either a row or a column. Can you kind of dive into that, how that process works, and how you have the exact same security guarantees in terms of data availability under this kind of system?
Yeah, so it's a question about sort of Celestia's erasure coding in general, or is it just like Celestia versus like compared to other DA schemes?
Yeah, Celestia compared to other DA schemes, because I know as well you guys are using fraud proofs instead of ZK proofs. So I'm just kind of curious how the whole system ties together. Yeah,
sure. So there's basically so first we should frame how data availability sampling works. So the way that it works is that you have like this block data, right, which is the actual transaction data. And you want to make sure that all that data has been published. But again, you don't want to have to download all of it because it could be a lot of data. And you might only have a phone. Like I'm not going to be able to download a 10 megabyte block every 15 seconds. And so what you do is you take this square and you use something called erasure coding, which basically adds redundant data in such a way that I can reconstruct the original square with a very small subset of this extended data. And so what that means is now if the validator wants to hide even a small amount of the square, like literally just like one bit of information, they need to hide a huge amount of the overall data that includes the extended square. And so that's what makes it so now I can sample the block at different spots. And if the validator was hiding something from me, chances are after 32 samples or so, if I never hit an unavailable spot, that means that like with very high probability, the whole block is available. That's in short and summary how data availability sampling works. Now, the kind of main difference between Celestia's approach and Ethereum's is that is the kind of erasure coding technology that we choose to use. So in Celestia, we use Reed-Solomon erasure encoding. And in Ethereum, they use what's called KZG commitments. The difference there is that in erasure coding, it's possible for you to basically forge, to pretend like you have to, when you extend the data, you can do it in an honest way, which is like to actually do the real, like actually extend the data, or you can do it in a malicious way where it looks like you extended it, but actually if someone then tried to use the data to reconstruct the original data, they couldn't. And so what you need to do is basically make sure that the erasure coding was done correctly. And so what you need to do is if every time like a block gets generated, the other full nodes download all the data and they check the erasure coding and make sure that it's correct. If it's incorrect, they generate what's called a bad erasure coding fraud proof. And they can send that fraud proof to all the light clients who can then say, okay, I'm going to ignore this block because the erasure coding is done incorrectly. Because if you don't do that, they would sample the data and think the block's available, but in reality, it's not because they couldn't reconstruct the original data, if you will. Now, in KZGs, the cool thing is that you can't like do it incorrectly. Like the correctness is kind of there already from the beginning. So you don't need to send around a fraud proof. So it's kind of like, it's very similar to the difference between an optimistic rollup versus a ZK rollup, if you will. So, and there's also, this is where the trade-offs come in. The KZG openings are very expensive and slow to compute. And so like, it takes a shitload, like a huge like block builder to do that. And it can also, the latency could be really big. Obviously, I think they're working a lot on parallelization. It's very similar to ZK rollups where you see a lot of like hardware optimizations and like trying to make this faster. And in the future, if KZG becomes viable and scalable, then it's something that we could absolutely switch to. But for right now, it just doesn't seem like the best trade-off, basically. And so we're going with the erasure coding approach. The other thing is that it's also possible to actually ZK prove erasure coding potentially. So it's something that we're actively researching. And so in the future, we might actually get the best of both worlds. And by the way, like the erasure coding is like doing Reed-Solomon sort of erasure coding is extremely optimized and very, very fast and very scalable. So if we want to scale to like much larger blocks, we know that we can do that in an efficient way. Whereas if you want to scale up with like larger blocks with KZG, it's like, holy crap, like that's, like let's say 100 megabyte block in KZG is going to be super slow. Like, so anyway, those are the trade-offs. That's probably a little bit too in the weeds.
No, that was great. I really appreciate it. I guess I had it backwards. So I thought that posting fraud proofs, you're assuming all of it is valid until there's actually a fraud proof submitted. And I thought that ZK proofs were more instantaneous, but they're more gas intensive, like you mentioned. So you kind of have to wait a longer period of time before you actually submit them. Is that what I'm getting? Like, is that where the actual delay comes from on the ZK side of things?
Yeah. So, I mean, so with the fraud proof scheme, you have to wait a certain amount of time to elapse that you didn't see a fraud proof to count something as final, right? And so that's where the delay comes from on that side. It actually could be quite quick to generate that fraud proof, but you want to be safe, like from your perspective, that like a fraud proof was generated and it got circulated to you. On the ZK side, it's a little bit the opposite. It's like once I get the ZK proof, or once I get the proof that it's valid, like I'm good to go. But it could take a while for them to generate the ZK proof to begin with, because it's just it's very like expensive to generate these proofs.
Okay, understood. Thanks for clearing that up for me. So I guess my next question would be, post 4844 on Ethereum, what is the data availability capacity of Ethereum versus what Celestia will be come launch in either the end of this year or 2024 sometime?
Yeah, so I saw some threads about this on Twitter about the proto danksharding like 4844 capacity. I didn't really understand it. As far as I understand, they're adding 1 megabyte of capacity. I could be totally wrong, to each Ethereum block, which is a good amount of data, and I think is going to like go very far to decreasing the cost for rollups on Ethereum. In Celestia's case, when we launch, we're going to have a maximum block size of 8 megabytes, and so that's going to be. I don't know. Like it's hard for me to compare. The other thing that I think the main thing that people need to realize, right, and this is because like we get into these arguments also with people about like from the Solana camp, which is like, oh, Solana has all this like throughput, and like even and then they take the 8 megabytes every 15 seconds, which is Celestia's initial sort of like block size and block time, and they say like, oh, that's only X number of megabytes per second of throughput. And the thing is that it's like apples and oranges in the sense that the whole point of building a data availability layer and doing modular blockchains is that there is no fixed throughput. You can increase the throughput as there's more nodes online. So we can actually flip a switch and say, hey, actually, you know what? We're going to change from 8 megabyte blocks to 32 megabyte blocks, right? We can continue to increase the block size. And so like, even just thinking in that mindset of like, oh, what is the capacity is kind of a misnomer. And the thing about, again, getting back to like 4844 is that it's not modular. There's no data availability sampling. So they can only, this is like a one-time increase. It's sort of like a Band-Aid sort of like fix to like add a little more capacity, but it's not like they can just wake up tomorrow and be like, okay, there's more nodes in the network. We're going to increase the size again. They can't do that until a full dank sharding is shipped, where they actually have true data availability sampling. And so that's really the core difference, is that Celestia's block size is uncapped.
And you mentioned there that the parameter, the limitation was the number of nodes online. And can you just dive into why that's the case?
Sure. So in the way that these data availability sampling schemes work is that you as yourself sample a bunch of different points of the block, right? And then you know that if he was hiding something, then you probably would have found at least one of the ones you sampled would have been unavailable. Now the problem is that what the block producer could do is basically only let the sort of light sampling nodes sample data, and not let anyone actually download the full block themselves. And so then what you need to do is you need to be able, for those light nodes that sampled, to be able to like basically put all their separate samples back together to reconstruct the original block. So you need to have enough light nodes that sampled enough data for you to reconstruct the original block. And so that's sort of like one of the security like properties or like requirements for this scheme to work. So that hopefully that answers your question. So then as you have more and more light nodes, more and more people like sampling on their smartphones, for example, all of a sudden you can start to increase the block size. And so the beauty of this is that, you know, monolithic chains have this negative network effect where the more users there are, the more applications there are, the slower everything is, or basically the more expensive everything is. It becomes like crowded and congested. And in a modular setup, we actually have these positive network effects where the more users there are, more applications, the more people running nodes, the more block size we can have. So we can actually have this positive feedback loop where, you know, we can continue to increase the block size to basically support more users and more applications.
No, that was perfect. I think that really helps paint the picture of why the number of light node sampling matters in this case, right? And it's beautiful that it's like perfectly scalable like this too. But I want to change tune just a little bit here. And one thing that was really hot on crypto Twitter over the past maybe 1 month ago was Rollkit, and really the idea of using Bitcoin as this DA layer. When you think about using Bitcoin as a DA layer, is that something that's practical to you? You know, obviously the 10-minute block times are the first thing that comes to my mind, but I'm curious about how that whole framework works in your head.
Yeah, I mean, so this again comes back to, well, let me give a background on what Rollkit is. So like back in 2021, when the project was still quite in an early stage, so there were a bunch of roll-up teams building on Ethereum, right? But they were building they weren't building roll-up software that was generalizable, that like anyone could take to launch their own rollup. They were building their own kind of proprietary stacks, essentially. And so we saw that as a problem because our vision is like everyone should be able to deploy a rollup. So we started building something that was meant to achieve that, and it kind of borrows a lot of inspiration from the Cosmos stack. And that's now what Rollkit is. But now, fast forward to 2023, there's a bunch of people like Sovereign Labs, for example, a ton of other teams building these sort of like rollup SDKs that share that vision. And so, and because we really believe in being like credibly neutral, right? Modularism, not maximalism, we've spun Rollkit out into its own separate thing, so that we can be independent and neutral. But anyway, Rollkit made a bit of a splash, as you said, when it basically integrated. Right now, it started with just integrating Celestia as a DA layer, but it recently integrated Bitcoin and showed that you could deploy, for example, like an EVM-based rollup on top of Bitcoin. And in terms of using Bitcoin as a data availability layer, I think the interesting thing about this is that Bitcoin has a ton of security. It has a really big ecosystem. And I also feel like Bitcoin is, as an asset, is kind of like we said, like kind of trapped and on a chain with not much functionality. And if it could get sort of like, if you could add more functionality, it could become like a more interesting ecosystem. And I think my hope is that this can kind of like spark more innovation and conversation in the Bitcoin community. But I still think there's a long way to go. Like, would Bitcoin actually be useful as a DA layer compared to other solutions like Celestia or Ethereum? Like you said, that the block times are really slow. There's really, the block capacity is also quite small, frankly. The data throughput is like pretty minuscule. But I still think it's worth doing. And in the future, like, I think basically the fate of every L1 is to eventually just become a DA layer, because that is really like the root level of blockchain is just consensus and data availability. So in the future, I could see Bitcoin kind of moving in that direction too, potentially. I don't know.
Right. No, I like your points there. I just quickly checked, and there's about $4.5 billion of wrapped Bitcoin on Ethereum. So there seems to be some sort of demand to get a more interesting use case for Bitcoin. But no, that paints a great picture there. And I kind of agree, though. Like, it's almost interesting because, right, so like Ethereum would be doing less than it is today if it was just a DA layer, whereas Bitcoin would be doing more, right? Today it's just a proof of work chain, but kind of like adding that data availability function would be an exciting development. And I'm definitely in the camp of seeing more innovation in the Bitcoin space. Would be super exciting.
Yeah, strong agree there, Dan. I have one more question for you before you go, Nick, and that's oracles. Have you thought at all about how Celestia could improve the current Oracle landscape? I know that's super niche question, so no worries if you don't have an answer for it, but I just kind of view that as like an Achilles heel of DeFi, and I'm curious if Celestia and data availability services would help at all on that front.
Good question. I don't think about oracles that much. I mean, it's its own like rabbit hole, I feel like, a technical problem to solve. I do think that one thing that could be interesting in the way that oracles like intersect with the modular stack is sort of just on the app chain side of things, which is that like what I would love to see is someone who builds like an oracle chain or rollup, I would say, on top of Celestia, that anyone, when they launch their like rollup, can easily like tap into and integrate and have like sort of a trust minimized bridge with. And I think that's sort of like the future of where I think rollups should go. It shouldn't be like, you know, a new rollup on every chain or like deploying a contract on every single chain that needs an oracle. It could be like some kind of like out of the box sort of like rollup, like Oracle as a service kind of rollup. And I think that's a lot of like, I think the future of the modular stack is going to have a lot of chains like that are sort of like, they specialize in one service that they sort of provide to the broader ecosystem. And I think Oracle is obviously like a very natural fit for that kind of sort of like use case.
Super interesting. Well, we're really excited to see how the project progresses. I guess you want to give us a timeline and then also where people can find out to learn more about you and Celestia.
Yeah. So as people might be aware, we are currently running our incentivized testnet, the block space race. We are, you know, a few weeks into the process and there's like another month or so left. And that's really exciting because we have, you know, hundreds of nodes running. We have like, I think 800 light nodes. So all over the world. It's the biggest live data availability sampling network to ever be created. So it's really exciting too, because basically this is the last step before we actually launch the real network, like mainnet. And so I'm excited to see how the block space race goes and what kind of like bugs we find, and so forth. And then depending on that, hopefully we will be able to launch mainnet later this year. So that's going to be a really historic moment, because to me, it's like the first modular L1 to really be birthed. And I'm hoping that this is sort of like a turning point in which the broader blockchain ecosystem starts to, we've been talking about modular blockchains for like years now, and I want to see them actually be live and be used. And I think there's definitely a lot of kinks to work out. Like, this is a whole new paradigm. There's a ton of stuff to be built, not just on the Celestia layer, but all the execution, settlement, shared sequencers, like wallets, all this stuff. There's so much to build, but it's exciting to know that this is kind of like the first step. And there's a whole movement of people, building projects that are aligned with this. And it just kind of feels unstoppable at this point, because enough people are modular pilled, and there's just so much momentum behind this new sort of mental model and paradigm of blockchains. And I think that the mainnet launch is really going to be like one of the sparks that hopefully like lights this flame. And so I'm excited to see where that goes. In terms of following us, like I would say Twitter is the best place. I'm Nick White, but instead of the I, it's an 8. And then we have Celestia.org is our main account. And we're always sharing things. I encourage people, if you're interested to learn more about modular blockchains, we have a learn modular section on our website. So it's celestia.org/learn. There's a lot of really good articles there and diagrams. I try to also sort of share my insights when I can. And if anyone has any questions, like we love when people hop on the forum and ask questions, or just, tag us on Twitter, because really this movement depends on people kind of like learning and understanding the philosophy and the design principles of modularity. And we're still so early on in this whole process of sort of like, activating people's minds in this new way of thinking, because it is a little bit, if you come from the monolithic standpoint, it doesn't really make sense at first. So you have to put in the effort of like learning a new way of thinking, but it's so fun and addicting. Like once you go down the rabbit hole and you become modular pilled, like you never come back. So, yeah, I'd love to like modular pill more people, basically.
Absolutely. Well, we'll definitely play our part in helping you with that. You mentioned 2 really great blog posts in the middle of this interview, and so we'll definitely link those in the description. But Nick, thanks for coming on, man. It was a pleasure talking to you. And honestly, just hearing the passion in your voice about what you're building gets me so fired up to keep doing what we're doing as well. So Nick, thanks a lot for joining us, man.
Well, thank you guys very much for hosting me.